Hi guys, welcome back. Sorry it's been a bit of a while since the last video. I've spent a bit of time creating myself a bit of a new work area out of recycled pallets, lights donated, old desks that have been donated, so we've got a bit of a work area to work in. Now what I want to talk about, the first part of this video, is how I've been able to manufacture these full carbon fibre tube, full carbon fibre rocket, completely manufactured in-house. So we've made the actual tubes themselves, we've made the nose cones. Now the fins themselves, I've not had a go at making flat sheet yet, so they're just actually cut out with the CNC. But what I'm going to talk about today is these little carbon fibre forged nose cones and how you can make your own little nose cones at home. Basically these mould, well, they're made from moulds, and the technique that is used is called carbon forging. Now to me, carbon forging is well, not even carbon forging in general is done with heat, big presses, and you can imagine forging car pistons and so on, but for some reason this technique is called forging. Now it is done with a compression and dies and so on and little moulds, so I can see where that's come from. But when you're making, say, normal carbon fibre parts like cars, say bonnets or even tubes, you're generally using a cloth like this. So this is a 3K carbon fibre cloth. It's all the cheap stuff. I think it's 210 grams, comes from Easy Composites, and that helps you make your stuff like your tubes. Now these tubes, they're only 0.5mm diameter. Now I have made some bigger ones that are on a 1mm diameter. Again, as you know, with carbon fibre, it is unbelievably strong. I could put as much pressure on that in the world and get a tiny bit of deflection on it. But this video we're going to talk mainly about how we've made these. Now these nose cones, obviously they're made with the forging technique. So what you're doing with this, you're using a different type of carbon fibre. It's still the same material, but it's called chop tow. Now it's made up of tiny little strands of carbon fibre that have thousands and thousands, miles smaller than the human hair, bits of carbon strands. So we use that in the mould, and then we use compression to get the actual mould to force the carbon fibre and the resin, force all the air out of it to try and make a solid nose as possible. Now the technique I've been using is 3-part moulds. Basically we've designed these from our open rocket simulation. We've then gone into CAD, designed the nose cone, we've made it into a negative, split it into a 2-part mould, and then added some recesses and a centre plug for compression. Now as you can see, this nose cone will still directly fit back into its original mould, so I've rattled a lot of these moulds off. It's basically a 2-part mould. First of all, it is sprayed with spray wax. Now we're using the Easy Composites, all their products, found them absolutely phenomenal. They've got some amazing videos on their YouTube page. I'd 100% check it out. So this is a wax spray. Now there's loads of different types of release agents, but because we're using 3D molds, now 3D mold, 3D printing's phenomenal these days. The quality is unbelievable. You can still feel the layer lines. Now this release agent, as it says on the tin, is high build. Now anything high build like a paint is obviously putting a thicker layer on than normal, but this doesn't give you the world's most perfect finish, but it gives you more than an adequate finish using a 3D printed mold. So the way it works is we've got 2 parts of moulds, these go together, we've got the internal, these are put in, we get roughly as close as we can to what we know that is the right amount of carbon fibre and to resin. We lay them out, we put them together, clamp them together. I've just been using tie wraps to keep it cheap, easy and simple. The bottom plug goes in, you get a lot of compression. If you've got it right, you should get a bit of seepage down the lines of the resin, and basically then you're leaving it for 8 hours. It cures, you cut your tie wraps, you split your moulds, and then if everything's gone well, you should have some perfectly formed little moulds inside. Now what you need to do then, bit of a trim up, run the knife down the edges. Now what I've found is I have 3D printed the inner diameter of this, stepped it down so it can fit into the drill, and I found that if I put them in the drill and work my way up from I've been using 120, 240 up to 500 grit, running through in the drill to clean them up. Now what I want to mention here is that carbon fibre dust is extremely dangerous, one, to your lungs, and two, the dust is so fine you don't want it all over your workshop, you don't want it on your machines. Now industrially they generally use massive suction and hoovers. You've got to wear your mask. I found that if you do a lot of the sanding, wet sanding, obviously you're not creating the dust particles. It's messy, but it's a lot safer. Wear your gloves and so on. One thing that I am not very good at. But yeah, so I've tried this technique in several different ways. I don't think I've got a nose cone knocking about that I can show you. But here's where we've been having a practice at a few different shapes. You can see that's a forged carbon bit. Now I've made this thing 3mm thick. Now I've jumped on it, I've standing on it. I'm pretty sure I could run over it in my Land Rover and it's not going to break. Here I've made another tail again. This one's 2mm thick, but again made in the same kind of thing, in a mould, pressed in. You get great internal dimensions and absolutely phenomenal. Now in the next video what I'm going to talk about is how I've made these carbon fibre tubes. Now these tubes are made with a process called roll wrapping, and I'm getting, if I say so myself, extremely good at it. If you have a look at the dimensions on these tubes, they're only 0.5mm thick. They've been designed specifically to run the Klima or the Estates 18mm motors, and they're unbelievably strong. Again, for a tiny little tube that's 0.5mm thick, you can only just squash them with stupid amounts of force. I'm pretty sure I could probably stand on that tube and get away with it. And then again we've made some smaller tubes, and these are a couple of tubes. Again, I'm very happy with these. They fit in absolutely perfect. You can join your tubes together, no problem at all. Now if you're looking at these tubes and thinking, why does one look different to the other? The larger one that I'm holding here has basically been ground down, and is a matte finish. Now if you glue into it, this is what you want, because there will be tiny bits of carbon exposed, so you get a lot more grip. The second one, it doesn't have anything glued externally to it, so it's had a layer of clear coat over the top. Now if you put the clear coat over the top, or lacquer as you want to call it, it obviously really makes the patterns pop. Same with this one. This one is an unground nose cone, sorry, both ground nose cones, but one of again has had a coat of lacquer over the top. But if you have a look at the dimensions, I'm very impressed with the technique. Obviously I learned what I've learned is not necessarily the right way to do it, but it's the way that I've managed to get a product, oh sorry, a part that I'm extremely happy with. And I can only say a big thanks to Easy Composites for taking the time, obviously, to make great products, and for their instructional videos. Everything that I've done here is directly copied off their videos. Thanks for watching, and I'll be doing a video in a couple of days to show you how to make the tubes. Carbon fibre tubes are ridiculously expensive, and this way you're probably a tenth of the price, because it's all labour and a bit of skill, but practice is everything. You're never going to get it right the first time, but each time if you improve, that's the only way you can go.